Hello everyone. So now let's solve a question which was asked in previous year 2015 GATE question, which is based on process management in operating system. The question here is the maximum number of processes that can be in ready state for a computer system with n CPUs, and these are the given options. So I personally feel that first of all let's understand what is being asked in the question. And then we'll come back to the question once again. Now here I have highlighted the main terms on which we have to focus. First is your ready state, and then it's talking about CPUs. So before that, let's understand what are the different scheduling queues in your operating system. There are three type of queues. First is your job queue, second is ready queue, and the third is device queue. In job queue, all the possible processes which are available in the system are being stored. What about the ready queue? Ready queue, the processes present in main memory and are waiting to be executed, means the processes which are just ready to execute, but they are just waiting for their turn, and it has to be decided by the operating system which process will be going for execution. And what about the device queue? Device queue is the queue in which the processes which are waiting for input output operation, and they are waiting for some resources, will be waiting over here, right? Now also let's understand the process state diagram to better understand this question. So in this process state diagram, generally we have five main states. So as we can as if I talk about this new state, so new state, uh, a process is said to be in new state when a program present in the secondary memory is initiated for execution. So here these are all the available processes, but they have not yet arrived into the main memory. They are just waiting into the secondary memory, right? uh, let's highlight it with a different color. And what about the ready state? All the processes which are just ready to execute, and they are present in the main memory. So here all the processes which are available in the main memory are there. Now what about this running state? So a process moves from ready state to running state when after it is assigned the CPU for execution. Now how it has to be decided? Like if I talk about this here in this ready state, we have a ready queue, and I have earlier also explained you the concept of ready queue. So what is a ready queue basically? So here we have a queue, and all the processes which are just ready for the execution are waiting for their turn. So let's say there are different processes, and all these processes are waiting in the ready queue, and they want to execute, right? So they here, if I talk about the processes which are present in the ready queue, they are not dependent on the processor, rather they are dependent on the queue size, and this queue size is again a part of main memory. So the number of processes waiting in the ready queue is independent of the CPUs, but it is dependent on the queue size. So if let's say the queue size is fixed, so there will be some particular amount of processes that can be allocated to the queue. Now coming to this running state. So in the running state, whenever a process has to be into the running state, it needs CPU, right? So we need CPU here. And out of all these processes, which process is going to be selected? It depends on the scheduling algorithms that we have studied. CPU scheduling algorithm, we have FIFO, FCFS, we have SJF, then we have RR round robin scheduling, and we have priority scheduling. So these are the different scheduling algorithms on the basis of which any of the process is going to be selected, and from the ready state it is going to the running state. Now coming to CPU, if your system has only one CPU, so the number of processes which can come into the running state can only be one. But what about the processes which can be in the ready state? There can be any number of processes depending on the queue size. But if your system has n CPUs, so obviously the number of processes which can be in running state can be n. But what about the ready state? Again is independent of the number of CPUs. Now let's see the question once again. The maximum number of processes that can be in ready state for a computer system with n CPUs. So whether a system has one CPU or it has n CPU, it is only going to affect which state? It is going to affect the running state. So here the number of running processes, here it will be one. So only one process can run because there is only one CPU available, or you can also call it as CPU or processor. And if there are n CPUs available, then the number of processes which can be in the running state will be n. So every process will be allocated to the CPU. Now, this was all about the running state. But what about the ready state? So if I talk about this ready state, so whether your system has one CPU or it has n CPU, it is independent of the number of CPUs. Rather, it is dependent on the queue size, and queue size is again a part of main memory. So the question is, like, you can now see the question, the maximum number of processes that can be in ready state. The question is based on ready state but not on running state. So if the question is on ready state, the number of processes is independent of n, because n is what? N is your CPUs. And I have explained you, if it is ready state, then it is irrespective of the number of processors. But if this question would have been running state, in that case your answer would have been n, right? Now let's go back to the question. So here the maximum number of processes that can be in the ready state of a computer with n CPUs is going to be independent of n, and there could be one more answer for this, and that is it is dependent on the queue size, right, or the main memory. But if this question would have been instead of ready state, it would have been running state, then your answer would have been option A, that is n. So I hope you understood this concept well. To get more updates, stay tuned to my channel. Thank you so much.